Hi, my name is Mr. Peck from Ideas Inc. School, and we are here today to discuss about chemical changes. This chapter contains a whole list of chemical reactions that we need to familiarize ourselves with. Firstly, let's talk about the differences between a physical and chemical change. A physical change occurs when no new substances are produced. This is a reversible change, and examples of this include material expansion and contractions, and changes of state. Chemical changes, on the other hand, involves chemical reactions that produce new substances. This change is also irreversible. Other evidences of chemical change is whether heat is given off or absorbed during the reaction. A reaction that gives off heat to the surroundings is known as an exothermic reaction, while a reaction that absorbs heat from the surroundings is known as an endothermic reaction. Chemical changes can be caused by light, heat, electricity, or by mixing substances together. Before we dive into the various reactions, please note that all chemical reactions must obey the principle known as the conservation of mass. This states that in a closed system, the mass of the reactants must be equal to the mass of the products. For instance, if all 50 grams of reactants fully reacted in a closed system, an equal mass of 50 grams of products are produced. In order to understand the concepts better, please pause the audio and refer to the notes. Then you will find how the word equations are written. Let's begin by discussing chemical reactions that involve light. During photosynthesis, with the help of light energy, carbon dioxide reacts with water to produce glucose and oxygen. When we write down the above reaction in a word equation format, please note the position of the reactants and products. The reactants, carbon dioxide and water, must be written on the left side of the equation, while the products, glucose and oxygen, must be written on the right side of the equation instead. The next reaction that involves light is the decomposition of film pigments. Film pigments contain silver chloride and silver bromide. When these compounds are exposed to light, they will undergo a decomposition reaction. Silver bromide will decompose back to its elements silver and bromine, while silver chloride will decompose back to its elements silver and chlorine. This is the reason why some pill containers and glass containers in the lab must be made with a dark brown color to prevent light from entering. Please note that decomposition is a class of chemical reaction that causes one reactant to break down chemically into multiple simpler products. The next chemical change that we will be discussing involves heat. During thermal decomposition, a metal carbonate can decompose to form a metal oxide and release carbon dioxide gas. For example, calcium carbonate, also known as limestone, will decompose to form calcium oxide and release carbon dioxide gas when heated, while zinc carbonate, when heated strongly, will decompose to form zinc oxide and liberate carbon dioxide gas. Combustion is another type of chemical change that involves heat. Combustion reaction occurs when a substance reacts vigorously with oxygen to release a lot of energy in the form of heat and light. For example, magnesium strips can be ignited with oxygen to form the white powder known as magnesium oxide. This reaction releases a bright white light and a lot of heat in the process. Another example involves the burning of fossil fuels like methane and petrol. Fossil fuels can undergo two types of combustion. They are complete or incomplete combustion. When a fuel like methane is burned with excess oxygen, it will undergo complete combustion. As a result, this reaction produces carbon dioxide gas and water vapor. However, when the fuel to oxygen ratio is low, it will undergo incomplete combustion instead. Incomplete combustion will produce extra products like carbon particles called soot and release carbon monoxide gas. Confusingly, there is another heat-based reaction that also involves oxygen. This reaction is known as rusting or oxidation. When iron is exposed to air and moisture, iron will undergo an oxidation reaction. Most metals will undergo oxidation when exposed to the surroundings. This causes iron to react with oxygen to produce iron trioxide, also known as rust. So what is the difference between a combustion reaction and an ordinary oxidation reaction? Combustion reactions often release both heat and light energy during the process, while oxidation reaction usually releases heat only. The last chemical change that involves heat is a combination reaction. Please note that a combination reaction is the opposite of a decomposition reaction. A combination reaction occurs when multiple reactants react chemically to produce a single product. This type of reaction is often used to demonstrate the difference between a mixture and a compound. For instance, when gray iron fillings and yellow sulfur powder are placed in a crucible, they form a mixture. However, when this mixture is heated, the iron and sulfur reacts to form a black iron sulfide compound. This new compound will no longer have the same chemical and physical properties as its starting elements. The next combination reaction involves a very reactive metal known as sodium and a very toxic reactive gas called chlorine. These two elements will react to form a compound called sodium chloride. This compound is harmless as it does not have the same chemical and physical properties as its starting elements. Thus, sodium chloride can be used safely when cooking. The next chemical change that we will be discussing involves the use of electrical energy. And to showcase this, we will be looking at the electrolysis of water. Please pause the audio and refer to the electrolysis diagram in the notes. First, the water has to be acidified in order to improve its conductivity. When a current passes through acidified water, it will decompose back to its elements, thus producing hydrogen and oxygen gas. But please note the volume of gas produced. In this experiment, the volume of hydrogen collected will always be twice the volume of oxygen. The last category of chemical changes involve the mixing of chemicals. We will take a brief look at 4 acidic reactions. There are 3 common acids found in the lab. They are hydrochloric acid, sulfuric acid, and nitric acid. The different type of acids will influence the name of the salt produced. For example, hydrochloric acid will produce chloride salts, sulfuric acid will produce sulfate salts, and nitric acid will produce nitrate salts. So here are the 4 acidic reactions. Number 1. When a metal reacts with an acid, a salt and hydrogen gas are produced. For instance, the metal magnesium reacts with hydrochloric acid to produce magnesium chloride and hydrogen gas. Number 2. When a metal carbonate reacts with an acid, a salt, carbon dioxide gas and water are produced. For instance, sodium carbonate reacts with nitric acid to produce sodium nitrate, carbon dioxide gas and water. When a metal oxide reacts with an acid, a salt and water are produced. For instance, potassium oxide reacts with sulfuric acid to produce potassium sulfate and water. When a metal hydroxide reacts with an acid, a salt and water are also produced. For instance, when copper 2 oxide reacts with sulfuric acid, copper 2 sulfate and water are produced. Note that the acidic reactions are known as neutralization reactions. We have come to the final part of this chapter. Here we will be discussing about how to test for gases. The test for hydrogen gas, a burning splint is used. If hydrogen is present, the flame will be extinguished and a pop sound is heard. Next, to test for oxygen gas, a glowing splint is used instead. If oxygen is present, the glowing splint will rekindle again. Next, to test for carbon dioxide gas, we will need to bubble the gas through lime water using a delivery tube. If carbon dioxide is present, a white precipitate will be observed. This causes the mixture to appear chalky. Lastly, to test for ammonia gas, a moist red litmus paper is used. If ammonia gas is present, you will detect a pungent smell and this gas will turn the red litmus paper blue. We have come to the end of the chapter. If you have any doubts, please approach Mr. Peck. Thank you for listening and have a nice day.